beautiful people, and welcome. In today's video, we will be talking about parallel lines. We will focus on slope of parallel lines and also how we can determine if two given lines are in fact parallel lines. All right, let's get started. As always, disclaimer time. I am human, so if I make a mistake, that's okay. Just let me know where the mistake occurs so that way we both can learn from my mistake. And as always, if you hear any noise in the background, I do apologize. We are recording from home, so that is Miss Sylvanas being a happy little kitty in the background. All right, let's get started. So the first thing we want to talk about is what does it mean to be parallel lines? Okay, so parallel lines are lines that never cross, touch. And the reason that they never cross touch is that they share the same slope. Now, they share the same slope, but their y-intercept are different. Okay, so parallel lines are lines that never cross or touch because they share the same slope, but their y-intercepts are different. So visually, how would that look like? Well, let's say, here's an example. Let's say we have two equations. Let's do y equals 2x plus 3 and y equals 2x minus 5. So if you recall previously, I believe it was in the beginning of second semester, we talked about slope-intercept form. So these equations, equation first and second, are both in slope-intercept form, which means the number in front of x is your slope. We call that lowercase m. And then this number after x with the sign included, that is your y-intercept. And that means 0, comma, b, where b is that number. Okay, so if you notice, our slope is the same. So in equation, let's number these. Let's call this equation number 1, equation number 2. So in the first equation, we have a slope of 2. In the second equation, we have a slope of 2. In the first equation, I have a y-intercept of positive 3. And in the second equation, I have a y-intercept of negative 5. Remember, you're always going to take the sign in front of the number. So how will that look like? Well, let me go ahead and sketch it real quick. I'm not going to use a ruler or anything, make it too professional. I'm just going to sketch it. So let's do 1, 2, 3. And then 1, 2, 3, 4, 5. So this is positive 3. This is negative 5. So let's graph the first one. So how do you graph these? Well, you start out, step number 1 is to identify your y-intercept. So it is 0, comma, this number. So 0, comma, 3 is where the first equation is going to cross my y-axis. This 2, this slope of 2 is actually in a fraction form, 2 over 1, which means 2 up and 1 to the right. I don't know if you guys can hear that, but someone's having fun on a motorcycle here. Let's wait for that gentleman to pass. Okay, so 2 up, 1 right. This is rise over run. If we had a negative slope, then that would change. All right, so let's do that. Let's go up 2 and to the right 1. So here's our second point on our first equation. And then I'm just going to roughly sketch it. Let's actually use a straight edge. And again, a straight edge is just something that's straight and has an edge. And I'm going to connect the lines, the points, excuse me. Make sure you put arrows on your lines because it is a continuous function. That means it goes on and on forever in both directions. Let's do exactly the same thing for equation number 2. So 0, comma, b is our y-intercept. Our slope is 2 over 1, so up 2 over 1. So here is our y-intercept. Up 2, 1, 2, over 1 to the right. There it is. Again. Here it is. Okay, so the black line is your equation number 1. This, I don't know, green, it looks green on the screen. Line looks like it will never truly cross with the black line. And the reason being is the slope, the rate of change is the same. So if this black line goes up 2 over 1, then your green line is up 2 over 1. And if your black line continues going up 2 over 1, your green line continues up 2 over 1. Because their rate of change is exactly the same for both equations or both lines, then they will never actually truly meet and cross. Therefore, they are parallel lines. So let's do an example number 2. And let's say you're given a question that says, find out if these, sorry guys, I'm actually gonna shut my window so that way all the cars going by are not too loud. Okay, so we're going to figure out if two slopes are in fact going to be parallel, okay? So let's say if they give you slope, let's say, let's call this slope A, and then we're going to call this slope B. And again, all we're looking for parallel lines is that exactly the same. So if you have a slope of 3, then you must have a slope of 3 in both. Therefore, they are parallel. Anything other than that, so let's say this is 3 and this is 1/3, not the same, so not parallel. For example 3, I'm going to do a review question on how to find slope. So this is a review on solving for slope. So if they give you something that looks like -1, comma, -11, and -6 and -7. Let me scooch this up and get this out of your way. And it's going to ask you to find the slope between 2 points. You need to be able to use the slope formula. And so what that is y2 minus y1. Make sure you have parentheses. x2 minus x1. And this is your slope formula. This is something you need to have memorized. You're going to use this in integrated math 1, in algebra 1, all the time. So now that you have your slope formula, you're going to label x1, y1, x2, y2, and then using that formula, plug in your numbers and solve. So in my y2 spot, I have -7. In my y1 spot, I have -11. In my x2 spot, I have -6. In my x1 spot, I have -1. Before I do anything here on the equal sign, I notice that I have 2 negatives that I can circle without crossing any numbers. That means I have a plus. If you cross out any numbers while you're circling, then it doesn't change into a plus. So now what do I have? I have -7 plus 11. I have -6 plus 1. And use your counters if you need to. -7 plus 11, 7, 8, 9, 10, 11. That means I have 4, 6, and 1. I have -5. I'm going to rewrite that. I have 4 and -5, and that is my slope. So we're going to be using this slope formula to find out our slopes to see, just like we did in example 2, to see if our lines are in fact parallel. So let's do an example like that. So example number 4, let me change colors. Example number 4 says, use slope to determine if lines, let me see if I can write, PQ and RS are parallel. So they're going to tell us that PQ, here are 2 points, -9 and -4, and -7, -1 respectively. And then we have RS is -2, 5, and -6, -1. So when you are solving a problem like this, you have to use the slope formula twice. You have to find the slope for PQ, and you have to find the slope for RS. So we're going to use the slope formula twice. I'm going to copy it down twice. So y2 minus y1, x2 minus x1, y2 minus y1, x2 minus x1. So let's redo that, this time plugging in our numbers. And before I plug in numbers, I'm going to label. So this is x1, y1, x2, y2. And I'm going to color code this. This is going to be x1, y1, x2, y2. Make sure you're using the correct information. So we want P and Q, so you're only going to be using this one here. So what do we have for y2? y2, we have a -1. y1, we have a -4. x2, we have a -7. x1, we have a -9. Once again, I see 2 negatives that I can circle without crossing any numbers out. That becomes a positive. So I have -1 plus 4, and I have -7 plus 9. This is 4 minus 1, which is 3. This is 9 minus 7. You can go backwards that way. 9 minus 7, 7, 8, 9, that's 2. So this is my slope for PQ. So PQ is equal to 3/2 for the slope. And now let's do exactly the same thing for RS. Y2 is -1, Y1 is 5, X2 is -6, X1 is -2. Once again, I see 2 negatives that I can circle to make it into a positive. Now this one here, I can't do it. If I try to circle these 2 negatives, that ends up crossing out my 1, and so you can't do it. So here, what do we have? We have -1 minus 5, and we have -6 plus 2. I have -1 minus 5, that is -1 and -5, which means -6. -6 plus 2, that is 2 minus 6, which is -4. So it looks like our slope might be a little bit different. So -6 and -4, but I know that I can reduce my fractions. I'm going to keep my negative and negative, but I know 6 is 3 times 2. 4 is 2 times 2, so I'm going to cancel my 2's. So then my slope is -3 over -2. Again, top and bottom match, so you cancel that out. So my slope, let me shift this up. My slope is 3/2 for RS. Do these slopes match? Yes, they do. So we can conclude that yes, lines PQ and RS are parallel. Let's do a recap before we conclude this video. Parallel lines are lines that never cross or touch. They share the same slope, but the y-intercept are different. Where they cross on the y-axis is different, but their rate of change is the same. When you have an equation in slope-intercept form, in order to determine if two lines are parallel, the number in front of x has to match, the slope has to match, the numbers after x are your y-intercept. For example, if you have a slope of line A and a slope of line B that are exactly the same, that means they are parallel. If they are not exactly the same, that means they are not parallel. For an example, we did let me back up. So we used the slope formula for example number 3. In order to do example number 4, we had to use the slope formula twice. So when they're asking you to determine if two lines are parallel, find the slope of one, find the slope of the other, reduce and simplify, and then tell me if they match or if they don't match. If they do match, yes, they are parallel. If they don't match, they are not parallel. All right, guys, this concludes this video. Like, share, subscribe to Teaching Still Modest Math. If you have any questions, please reach out. If you find a mistake, also let me know so we can both learn from my mistake. Thank you again for watching, and I'll see you in my next video.